Today we're going to discover the secret of the perfect drone ball. Let's start with the unboxing. Doing an unboxing of something that's already open, but you get it. We noticed that this crazy toy was being made in China and becoming a trend. We decided to buy it with a lot of skepticism. Because you watch those videos on the internet. People throw it, it works like a boomerang. The thing flies like a drone, and in real life, it's not always like that. Besides, these things tend to be pretty fragile. So since it was really cheap, we found it for 20 rays. We bought 4 boxes right away, just to make sure at least one of them. And do you know what happened? One doesn't charge anymore, and the other one's LED stopped working. But I think we can still test it. It comes in a box like this. We found 2 different boxes, but inside the product is exactly the same, with 3 dazzling colored lights. Your Fly Nova Pro will look like a neon shooting star when you throw it across the sky. Morale, let's open the box, right? Oh. It comes with a little ball. Here's a USB cable for us to charge it. It's still micro USB. Remote control and manual. In the manual, it already has another name. It's Jitter Drone. Jitter means to shake, but here they're already calling it a drone, and it has a different name from the box. It's kind of weird, right? Looking at it from the outside, it's a little plastic grid shaped like a ball. This little grid is really flexible. This material is cool because you can drop it on the floor without damaging what's inside. And what's inside? It's a motor with some propellers. We'll take a closer look at that when we take it apart. And there's a little LED strip. To turn it on, there's a button down here, on the same side as the micro USB port for charging. If you press the button here, it turns on. It's tough to press the button with your finger. See? It blinks 3 times and turns on. And then with the remote control, you can turn it off. After all, you won't be able to press the button again because it's spinning. Look. So? In the video, we can't really show wind coming out, but just imagine there's a curtain of air down here. Like it's a drone. It's not a weak drone at all. This makes it fall much slower than a regular object, see? Let me put some toilet paper here so you can see. Now it's clear, right? What's the trick with this thing? It's not just letting it fall. The idea is to throw it up, and it'll stay in the air much longer. Look at that. If I throw it here, it already takes a long time to come down. And it behaves kind of weird. Let's test it outside. Whoa.
Whoa!
Let's see, huh? Look. No! No! It's spinning inside the...
Faster than I expected. It doesn't have those nets.
It does. Wait. Is it still blinking?
I thought it'd break pretty quickly. Do you think it spins? It doesn't spin anymore. Hold on.
Now that's what I'm talking about, huh? Look. Wow. Go. Come on, whatever happens, happens. Ooh. Let me see. In theory, it'll come back to me. It came back. Fernanda specialized in throwing the ball into the pool. No, wait, hold on. Inside the studio, I could make it come back.
But in the studio, then, you were throwing really softly.
It was much weaker than you'd want to see.
Look, throw it gently.
Look, throw it gently. It comes back.
Which way is the wind blowing?
Forward. But at a 45-degree angle. That's it. Okay. And throw it gently, really gently. That's it, just about 30 degrees forward.
Okay.
Wow, I'll throw it to you now. Watch. No, I think it got weak already.
Is it spinning slower?
Yeah, just as we mastered it, it's already over.
You have to charge it a long time for it to last only a short while?
Let's find out now then. What's the secret behind this thing? What's the physics here? Especially what kind of mechanics and engineering are inside to make this kind of drone, this spinning top, fly in the sky. The first thing is that, in fact, it's a spinning top. It gets a lot of stability from having something spinning inside. I'm going to spin the top here, just so you can see how stable it is. How is this object so stable? How is it possible for it to keep spinning on the tip of my finger with all this stability? It's precisely because it's spinning. When something is spinning, it gains stability along its axis. It's hard to change the axis position. This is called the gyroscopic effect. In fact, when it starts losing momentum, the axis begins to make this movement here that we call precession. And yes, in this little ball, we have the same effect because what's spinning is the motor inside. It's working like a spinning top. You can see that even when precession is happening here, it still has a lot of stability. Only at the very end did it fall off my finger. There was another physics question that kind of blew our minds, that took us some time to understand, which is, how does this boomerang effect work? Like a boomerang. Because when I throw it in a certain position, it comes back to my hand. This dashed line here is the direction I sent the ball, okay? I threw it so it would follow this trajectory, which is about 45 degrees. So let's imagine the ball started here. A very important detail is that for this to work, I have to throw it at about 45 degrees with the wind blowing in this direction. So I throw it this way, and the wind is blowing this way. You can notice that this wind is kind of against the movement it's making, right? The wind is going this way and it's going that way. So the wind kind of slows the ball down. But at the same time, the wind is also a bit downward. So both things will happen at the same time. It will slow the ball down, but it helps keep it aloft. So it can get here without any problem because the wind is giving it some lift. But it loses momentum along the way. It slows down this forward movement until it reaches the peak up here. It's still windy because it's still on. You might think that when it gets here, it would tend to fall. Okay, but it's not going to fall straight down exactly because there's wind blowing backward. If there's wind blowing backward, it tends to fall this way. So I throw it this way, it loses momentum because of this wind. The wind goes against the movement it's making, but at the same time, it helps it float. It gets up here. When it has completely lost its momentum, it comes back. It will want to fall, but it comes back to me because the wind is blowing in this direction. All of this is because of the position I threw it from, okay? I threw it with the wind kind of from the side. If I throw it with the airflow level, which would be like this, the ball will go higher than it normally would, so its trajectory will be like this and it will fall on the other side. So its movement would be much greater than if the ball were turned off, because this wind helps it float. And there would still be a third option, which is to do the same thing but with the wind coming from behind. Now, the wind helps the ball both go up and move forward. It's the opposite of the boomerang. It's going to do something like this. Look. It goes really far. And it has a beautiful trajectory, right? A parabolic trajectory that keeps the ball in the air much longer than we were expecting. And of course, you could also mess up and throw the ball upside down, blowing it upwards. And then the trajectory will go straight to the ground. But let's start opening it up now to see what's inside. I'll have to figure out which one wasn't working. Yeah, this one isn't charging anymore. The battery stopped charging. This is the one that's going to be sacrificed. I think I can open this up without cutting it. Ooh, ha ha ha. Look here, the guts of this little thing. It's already coming apart on its own. My God. Calm down, my boy. I haven't even started taking you apart yet. The first thing we notice here is that it's not a propeller like a drone. There are two propellers spinning at the same time. There's a tiny one here in the front with 3 blades, and a much bigger one in the back with 6 blades, where the LED strip is attached. What's the logic behind having 2 propellers? You might have noticed that helicopters don't just have those blades on top. I don't even know if I can exactly call them propellers. People call it a rotor because it has the shape of an airplane wing spinning. But on the tail, the helicopter usually has another, slightly smaller propeller, right? What is that for? If it only had the one on top, while the top part spins, the bottom part also spins in the opposite direction because the top propeller pushes against it, causing it to rotate the other way. I think there was an Iberay Respond episode where someone asked why helicopters have a rear propeller, and I made a kind of laser-cut helicopter replica. I put a little motor on it and then put it in the pool. And there you can really see that the helicopter tends to spin in the opposite direction of the propeller. So the propeller on the back solves this. It prevents that movement. But another way to solve this is to have 2 propellers spinning in opposite directions. In fact, there are a lot of big helicopters that use 2 rotors on top, so they don't need a tail rotor. And that's what's happening here. We have 2 propellers that are going to spin in opposite directions. You can even see that the position of the blades is reversed. The top blade is like this. The bottom blade is like this. This reversed position is important because it makes it so that even spinning in opposite directions, both propellers blow air in the same direction. Otherwise, we'd have a crazy ball blowing air to both sides at the same time, and we wouldn't get this flying effect. Another very interesting thing that we can already notice here is that there's only one motor for both propellers. How is that possible? How can the motor spin two propellers at the same time in opposite directions? It's actually pretty simple. The motor is part of the larger propeller assembly, but at its tip on its shaft, there's a small gear that's attached to the smaller propeller. So when it spins, it makes both things spin at the same time. It's kind of strange, right? I wonder if I can reproduce this with a swivel chair. Imagine that my legs are the larger propeller, the bottom propeller. This here is the top propeller, and my body is the motor. Look what happens when the motor starts to spin. Both propellers are spinning at the same time, and there's only one motor that can spin two things at the same time in opposite directions. And now I don't know how to stop this without destroying something around me. I got a little dizzy.
No, I asked if he started just spinning it with his hand, or if he gave it a little push with his foot.
No little push with my foot, Fernando. Be careful with this, okay? Look at this. Stopped, right? Nothing at all. Let's continue our teardown now. The capsule is just fitted in. There are no screws here. All of this opens up. One thing that really caught my attention was that the battery and the motor spin like crazy, along with the whole assembly. And for that, the weight has to be very well balanced. When you have something spinning, if one side is heavier than the other, it will start to work like a cell phone's vibration motor. It will start to shake. In fact, what's inside the cell phone that makes it vibrate is exactly that. It's a weight on the tip of the motor that's heavier on one side than the other. So I imagine that somehow they perfectly calculated the position of the motor and the battery. Inside here, the motor is really tiny, and the battery too. Both are extremely small, and that's why this battery barely lasts at all, right? It's basically a little capsule, like a tiny piece of gum here. I wonder if we connect this directly to the USB. Will it turn on? Is there some kind of protection so it doesn't turn on while you're charging? I doubt it. It turned on. Listen to that little sound. Ouch. I burned my finger. Listen to that little sound. Now it's charged. The motor keeps running even unplugged from the USB. Can I put it back together? Has it stopped already? It doesn't want to spin. Let's take apart the rest of it now. I think it's really crazy how this little board handles so much. Because first, it has battery charging control here, right? You plug in the USB, and it charges the battery. It probably has some protection so you don't keep charging the battery forever and stuff. It shuts off at the right moment. I press a switch with my finger that's connected to a timer, since the motor starts about 3 or 4 seconds later. There's the LED control and the motor control. And there's even a remote control receiver, so I can control it from a distance. All of this on a board the size of a coin. Dissection complete. We understand how this thing works. I don't know about you, but I can't look at this thing without thinking about making a vehicle with it. I'm going to try to make something here that I had already promised a while ago on Manual do Mundo, but not this size. Anyway, as I build it, you'll start guessing what it is. I think now we have a hovercraft, and it's over. Our verdict about this little ball here, it's a really cool toy. You can do all sorts of crazy tricks with it. Once you get the hang of playing, you can do cooler and cooler things. I think if you have a cat, it'll be even more fun. Because when it falls on the floor, it moves around like crazy. But there's a problem. It's not exactly the highest quality thing. Out of the 4 we bought, one had its LED burn out, the other one stopped charging. This is the one I just took apart. I found that there came a point when it wasn't charging properly anymore. And the battery doesn't last very long. Look, this one is already weak. It's not coming back very well anymore. But there's some really well thought out engineering inside here that it does have. I think it was worth it for him to take it apart. And then One of the coolest toys we've taken apart is a little train that can make a line of dominoes. It's another toy that involves a lot of mechanics and does it with very little electronics. It's worth watching.